Hello everyone. In this video we are going to discuss Cannizzaro reaction in much more detail. So this is a very important reaction of carbonyl compounds in which those carbonyl compounds participate which don't have alpha hydrogen or there is absence of alpha hydrogen. The reaction happens in concentrated OH minus, or we can say concentrated OH minus is giving you as a strong conditions for nucleophile. And at the end of the reaction we'll observe that it gives formation of alcohol and salt of acid. So to start off the basic detail, I am taking very simple reaction where HCHO attacks with HCHO in presence of concentrated OH minus. Let's observe this reaction carefully. In this reaction, one thing is very clear, that around the C double bond O, we can't mark any alpha hydrogen. There's no alpha hydrogen in both the reactants. So it is fulfilling the required condition of no alpha hydrogen. And presence of concentrated OH minus ensures that this will act as a nucleophile. So what will this do? This can attack on this carbon, and meanwhile this bond will break towards oxygen. So we can expect HCO minus hydrogen OH. In the very next step, we discuss migration of hydride, which will be a nucleophile. So H minus migration from one place to other place, where H minus is acting as a nucleophile, will convert this part of the reactant into HCO minus hydrogen, and we will have hydrogen at this place. Now can you tell me what will happen to the other structure, this structure? So this structure will take shape of HC double bond O, OH, formic acid, and this is methoxide ion. We all know acids have no right to keep their hydrogen with themselves, as in any acid will lose out hydrogen. And who's going to gain this hydrogen? This O minus. So what is the end result of this reaction? We will get CH3OH as one of the main product. Along with that we get HC double bond O minus, which is formate ion. So we get formate ion and we get methanol. So this is the product of this particular reaction in the given scenario. Now if you go to the rate determining steps and other part of this reaction, this hydride migration is a crucial step. And if the reaction is given in some different ways, let's say HCHO reacting with some DCOD and reacting in presence of OH minus, certainly concentrated. So try to understand that OH minus will attack on C double bond, no doubt about it. But which C double bond though? There are two C double bondos now. One is HC double bond OH, other is DC double bond OD. When we talk about DC double bond OE, the thing is this particular thing which has deuterium here will have more electron releasing effect. So we know as compared to hydrogen, deuterium is having more electron releasing effect. Electron releasing effect. So due to this, what will happen? Can I say the requirement on carbon, on this particular carbon, the requirement on this carbon to invite any attack from nucleophile will be more in which of the cases? So you are given two options, option 1 or option 2. Where exactly we have more requirement? Certainly where there is less supply. So supply is more in deuterium, so automatically the supply is less in the first case. So the first attack should happen at this location. In this attack, we'll learn one thing. In this attack, what is going to happen? Let us see. So in this attack, it converts into hydrogen, CO minus, hydrogen, and one more OH. Now we can discuss same thing, hydride migration, but this time this hydride is going to migrate and going to attack on which position? It will attack on this particular carbon. When this attacks here, this breaks. So what are the things that you can form out of these two things? The first one becomes HC double bond OOH, as in the previous case. The second one becomes DCO minus D and at this position we got hydrogen. Alright, so after getting this thing, the last and final step is O minus grabbing hydrogen from this place and setting it free. So what's the answer? It will be HCOO minus, which is salt of acid, or we can say formate ion, and the other part is CD2HOH. Now, see, the trick is very simple. This OH which is written here, so this particular H is coming through the H which has been taken from the acid. So this is the result. So we can practice some more question where let's say you're given HCHO with DCOD in OD minus, or DCOD with DCOD in OH minus, or DCOD in DCOD with OD minus. So all these questions will be very easy after this discussion. I hope you like this video. So if you liked it, please share and tell your friends also. Thank you.